In this video, we're going to continue to talk about describing quantitative data, and we're going to finish out Chapter 2. Okay? So, in the previous videos, we talked about measures of center, scale, and variability, like the mean and the median, or the standard deviation and variance. But there are a few other measures that we can talk about that describe variability as well. Okay? And these measures are called measures of position. Okay? But they can still describe center and variability. So they're kind of like off to the side compared to mean and median, standard deviation, and variance. Okay? But they can still get at that stuff. Okay? Center and variability. And so when I talk about measures of position, I'm usually talking about something like a percentile. Okay? So the pth percentile of data is the value such that p% of the observations fall below that point. We've all, in some way, shape, or form, come into contact with percentiles in our life if we've taken a standardized test. Okay, so I remember when I got the when I took the SAT or ACT, okay, or even when you took state standard tests, that they gave you what percentile that you're in. Or when you're a child, they have growth charts, and you can be in the whatever percentile of growth charts. The percentile, say I was in the 95th percentile of my SAT math score. Okay? That means that I did better than 95% of the people. Or, in other words, 95% of the scores fell below my score. So hopefully that makes sense. That's a percentile. So if I was in the 10th percentile of growth charts, of like a height, for children my age, that means that I'm only taller than 10% of the people, or 10% of heights fall below my height. Okay? We can talk about special percentiles, okay, which often come up. Those special percentiles are called quartiles. Okay? They're called quartiles because they cut the data into quarters. Right? There are 3 percentiles: the 25th, the 50th, and the 75th. Okay? We call the 25th percentile Q1, okay, the first quartile. The second quartile is the 50th percentile. We call that Q2. And, interesting fact, the median, by construction, is the second quartile. Okay? Because it is the exact middle of the data, which means that 50% of the observations fall below it and 50% of the observations fall above it. Hence, 50th percentile, second quartile. And then the third quartile, Q3, is the 75th percentile. Okay? We'll use these quartiles for a lot of what we're going to do in the next couple of minutes. So we can use the quartiles to come up with another measure of variability. Okay? So in addition to standard deviation and variance, we can talk about the interquartile range. Okay? The interquartile range. So the interquartile range, or shortened to IQR, measures the variability in the middle 50% of the data. Okay? And specifically, it's Q3 minus Q1. Okay, so IQR is Q3. Sorry, I'm going to go back here. Q3 minus Q1. I don't have that written down, but make sure that you do. Q3 minus Q1. And since these percentiles are having to do with the median-ish type things, they are resistance measures. So the IQR is a measure of variability that is a resistance measure. Okay? So if I ask you, what measures of center and variability should I use if I have skewed data, you should answer median, and IQR, not mean and standard deviation. If it's symmetric, mean and standard deviation. If it's skewed, median and IQR. IQRs, so quartiles and then IQRs, are helpful in detecting outliers. Okay, so how do you, in some sort of analytical way, detect if an observation is a potential outlier? Well, a common procedure to do so is to see if points lie more than 1.5 times that IQR above Q3 or below Q1. Okay, so if you calculate Q3 and then you add 1.5 times the IQR to that, and there are still points above that sort of cutoff, those points are labeled potential outliers. Okay, now our book and most people do 1.5. There are other ones who are sort of more conservative, and they multiply by 3 and not 1.5. Okay, just keep that in mind. Most people do 1.5. We will do that in this class, but there are others out there. As an example of mean versus, this should say standard deviation versus IQR. That's my bad. We're looking at standard deviations and IQRs for some data points here. So if you see in the data I have up top, okay, this is code from the programming language R, but don't let it fool you, or don't let it scare you. I just have some data points, 12, 15, 14, 17, 19, 23, and 18, okay? And I calculate the standard deviation and IQR for it. Okay, that's the top. So you'll see that the standard deviation is 3.6 and the IQR is 4. I don't want to, you can't compare those directly. So if the standard deviation is sort of different than the IQR, that's okay. It doesn't mean one is wrong. It just means that the two aren't measuring the same thing. Okay, but if I go down to my second data line, okay, you'll see that I kept almost all the numbers exactly the same, but instead of 18, I added 2 zeros, and so 1800, okay, which is a clear outlier. It's much larger than the rest of the data. So what happens when I just change that one number? If you look at the standard deviation, it changed drastically. Yes, it went from 3.6 to 674. Okay, so that's a drastic change. The IQR, however, went from 4 to 6.5, okay, which changed much less. Hence, it is a resistance measure. So hopefully that made some sense. Okay, so there's another method. So I talked a little bit, very briefly, when I talked about interpreting the standard deviation using the empirical rule. I mentioned very briefly that it can be used to tell me if something is weird or not. All right? There's another way that we can do that, and it's something that's going to come up a lot in this course. It's called a z-score. Okay, a z-score is when you take an observation from a set of data and you subtract it by the mean and then divide by the standard deviation. Okay, so z is equal to an observation, x, minus the mean, x bar, divided by s. Okay? So you may ask, well, why the heck are you doing that? What does that do for you? This new z, okay, this new value, tells you how many standard deviations away from the mean a point is. Okay, so that may not make it much better at the moment, but if I go back and I think about the empirical rule says if you're like between positive and negative 1 standard deviation, then you're pretty much in the center. 95% of the observations lie between plus and minus 2, and almost all of them lie between plus and minus 3 standard deviations. So if I get a z-score of 4 or 5, then I know that that observation is uncommon, or maybe even an outlier. Okay, so this is a tool, a numerical tool that we're going to use often in this course to do things like this. Okay, so that was a z-score as a bit of a transition away from what we were talking about. But now back to what we were talking about before. Okay, and those are measures of position. So we talked about percentiles and quartiles and IQR, so on and so forth. Okay, and so I can use those measures to create another plot for quantitative data. So we didn't talk about a box plot, which is a very popular plot way back when we started talking about graphical summaries, because we hadn't been introduced to measures of position yet. So now we are, okay? And so here's a box plot, okay? A box plot can be very confusing at first, but it's really not that hard, okay? There's a box, okay, which is the main part of the plot, and then there are whiskers. Some people call this a box and whisker plot, okay? I'm just going to call it a box plot. The whiskers extend from the box in either direction for a certain length, okay? And then we have some extra stuff that we'll talk about. The most important part is the box, okay? So there's a box, and then there's a vertical line in the box. That vertical line is the median. So it's Q2, and then the ends of the box are Q1 and Q3. Okay, so the box represents that middle 50% of the data. And so you can find the IQR by subtracting the right side of the box minus the left side of the box. That'll give you the IQR. And so that's the middle. The whiskers have to do with detecting outliers. So on the right side of the box, you'll see that the whisker extends to a certain point, and then afterward, it looks like the line gets thicker. The line actually stops right where my arrow is, and then after that are a number of dots. Okay, there's just so many dots that it looks like a singular line. That cutoff point is the Q3 plus 1.5 times the IQR. Okay, so they cut it off there, and then any point that is larger than that is just a dot. Okay, on the left-hand side of the box, you'll see that the whisker is much shorter, and that's because the whisker will only go to the smallest point in the data. Okay, so it doesn't actually extend all the way down to Q1 minus 1.5 times the IQR. Okay, it goes to either that point or the smallest point in the data. Okay, but a box plot is another way that you can represent a quantitative data in a graphic. Now, the last thing I want to talk about is comparing multiple groups. Everything that we've done so far, measures of center, measures of variability, plots, everything has been with one single variable. Well, we can also use these plots that we learned about that are like one singular one to compare multiple groups. Both histograms and box plots can compare multiple groups. So here is a graphic of different plots, okay, all put together, and we can compare how the shape of these look. Okay, so histograms and box plots on the same. Okay, for comparing multiple groups, box plots are preferable because if you look at the histograms here, they don't quite match up. Meaning, visually, it's hard to look and and move your eyes all around to see the differences. But for a box plot, they're all on the same plot, and you can tell the differences easily. Okay? So, that's it for Chapter 2. Hopefully not too bad. If you're watching these videos before you do the assignments, you'll have homework online for this kind of stuff. You'll also have a data analysis project where you'll identify different variables, and you'll also have sort of a larger project that you are going to work on as a class altogether to explore different types of plots. Okay, we only show the very most basic types of plots here, but being able to plot data is extremely important, and people have done it for a long, long time very well. And so you're going to explore all different types of plots from all different parts of the world and all different eras. Okay, not all different eras, but a lot of different eras. So that's it for Chapter 2.